Okay, so now that we've learned how to find our pieces of a rational function, right? So we should be able to take a rational function. We should be able to find it, one or more x-intercepts, or maybe zero, but a y-intercept if there is one, vertical asymptote, there could be more than one, and the horizontal asymptote. Our goal now is to take our information and get it on a coordinate plane and make a sketch of the graph. Just like with polynomials, it's probably not going to be the most exact, super accurate graph, but we should at least have the shape. We should be able to indicate where it's above the x-axis, where it's below the x-axis, where there's significant features. So to start with, we had our function h of x equals x minus 4 over x plus 7, and we're just going to put what we know on the coordinate plane. So we have 4, 0, we have 0, negative 4/7. I mean, it's about a half, right? Just put it down there somewhere. It's more important to know that it's below the x-axis than it is to actually know that it's negative 4/7. The horizontal asymptote is y equals 1. We want to make that a dashed line. And also, I tend to put arrowheads at the end of my asymptotes, but I don't put them at the end of my x and y axis. You can use graph paper or a grid if you want. There's one provided in the note packet. You could also graph it by hand, which is kind of my preference. And then here we have x equals negative 7. So we have all this information, and we may have enough to kind of guess what the graph's going to look like, but let's look at a more systematic way. Okay, so what we're going to do to make this is we're going to use what's called a sign table. Not like the trig function, but like positive or negative sign. And we've made things like this before. All we want to look at to make our sign table, though, is we're going to make like a number line. It's your x-axis. Look at any significant happenings on the x-axis. So we have a vertical asymptote at negative 7. Okay, so on my line here, I need to put negative 7. We have an x-intercept at 4. That's the only two things I put on there. Don't put anything from the horizontal asymptote. Don't put anything from the y-intercept. We're just using the x-axis. Now, I like to, because I know negative 7 is a vertical asymptote, so I'm going to put an open circle there to remind myself that there should never be a point there. 4 is actually a 0, so I'm going to put that there. And what we're going to take advantage of is the fact that rational functions are not continuous, because we know that this has an infinite discontinuity, correct? But the rest of it will be, parts of it will be continuous, right? And unless you're going from, now when you go from one side of an vertical asymptote to another, there's going to be a discontinuity. It could be up here, and then it could jump to down here, or vice versa. Or we don't know. That's why we have to test either side of it to see what's actually happening. But everything between the vertical asymptote and this x-intercept is either all going to be above the x-axis or all going to be below the x-axis, because there's nowhere to cross over, right? You can only cross the x-axis at an x-intercept. So if you so what we're going to take advantage of that. We know that every number between negative 7 and 4, if we plug it into our function, they're either all going to be positive or they're all going to be negative. And to us, positive means it's above the x-axis. Negative means it's below the x-axis. So let's take a look. It helps to have it in factored form, which we already have. I guess I smudged it there. So our function here is h of x equals x minus 4, x plus 7. And I'd recommend writing this out for now. You're going to get to where you do enough of these, you might not need to make a sign table, but for now it's a great thing to fall back on. And this is a really easy function. If they start to get more complicated, it's good to have good foundational skills. So what I'm going to do is within each of these intervals, so this goes from negative infinity to negative 7, doesn't it? Pick any number in that interval. So let's say I'm going to test negative 10. Look at our function. If I put negative 10 in here, negative 10 minus 4 is negative. On top, negative 10 plus 7 is negative. A negative divided by a negative is positive. So that tells me that for that interval, right, from negative infinity to negative 7, the graph is going to be above the x-axis. Let's test between negative 7 and 4. And actually here, we already know this point, don't we? That's the y-intercept. So you could go ahead and test, but we know it's going to be negative because we've already done the work. And you can test, it's not very hard to test either. Out here, let's pick maybe 7, some number bigger than 4. When you plug it in, you'll get a positive over a positive, which is a positive. So what this tells us is, to the left of the vertical asymptote, it's all going to be positive. In between the vertical asymptote and the 0, it's going to be negative or below the x-axis. And then to the right of this, it's going to be positive or above the x-axis, which is good information. Now, we have to combine that with the fact that we have a horizontal asymptote, which shows us our end behavior. Right? So we know as we go to the right, it's going to have to get close to this line, correct? And more importantly here to get started, as we go to the left, it has to get close to this over here. Right? So we know up here is positive, don't we? So that means as we approach this asymptote, our asymptotic behavior is going to be to go positive. Right? Because if you went negative, well, you'd have a negative number, plus you'd have to cross the x-intercept, which there's no, or the x-axis, and there's no x-intercepts there. So that tells us this has to go up positive, and it's going to come down here and approach the horizontal asymptote. Then here, we know this interval we said is negative, didn't we? So if it's negative, as it approaches the asymptote, it's going to have to go negative. Right? It's going to come up, it's going to hit this point, it's going to hit this point, and then we said to the right of 4, it's actually positive, isn't it? Which is going to allow it to get close to the horizontal asymptote. So here it's going to look something like, I think my point's bigger there, but it should look something like that. Now, it should look like it's not going to cross the asymptote, right? So make sure you don't like draw across it. That would be a problem. Does that make sense though, this setup, how we're looking at this? Okay, so again, the sine table, again, you may be able to get away without using it, but it's a great thing to fall back on. We used it a little bit with polynomials. Now we're looking at it more with rational functions. All right, here's our second example. G of x equals 3x over x minus 2. Okay, we know from prior the x-intercept, y-intercept, vertical asymptote, horizontal asymptote. We have all those listed there. I went ahead and put those on the graph. We just need to figure out now where the rest of the curve is at. Right? So we only have one point that we know, and that's the origin. It's an x-intercept and a y-intercept. Here's x equals 2. Here's y equals 3. Right? So we know as we go to the right, as we go to the left, we're going to approach this horizontal asymptote. The thing is now, we need to figure out where our curve is at. So let's go ahead and make a sine table. It'll be a pretty quick one. The only values we'll need will be 0 and 2. Right? 0 is where there was an x-intercept. 2 was a vertical asymptote. We'll go ahead and test a number from each region. So maybe, -2 and then 1 and then 4. Just remember, when you test, you have to test between the two numbers. You can't pick one of the numbers and test it. Right? 'Cause if you pick this, you'd just get 0. And if you pick this, you'd get undefined. You have to pick something from inside the interval. And let's see, we had 3x over x minus 2. So if we put -2 in, we get a negative on top, right, the numerator, a negative on bottom, which is a positive. So from 0 to -infinity, it's going to be a positive value, which we expected, right, with the horizontal asymptote. Any guesses what's going to happen here? It's going to drop. Yeah, it's kind of the typical thing we see. So here we get positive on top, negative on bottom, which is negative. So I can actually draw that part of the function because it's everything to the left of the vertical asymptote. But since anything is negative in this interval, that means that we're going to have asymptotic behavior that goes to -infinity. Because between where we tested at 1, is negative. There's no x-intercepts there. It can't cross back over to go up. So it has to look something like this. Okay. Again, you can't create x-intercepts. Like that's the kind of the big thing. With polynomials too, that was the thing we saw, right? If you tried to use your shapes and your multiplicities and you can't get it to do what you want it to do, it means there's probably something wrong. It should work. So for 4 here, we get a positive over a positive, which is positive. Again, we never cross the x-axis. Right? We know it's going to approach this line as we go to the right. Since it's positive, it's going to go up. Right? That's the positive direction. So then our graph would look something like that. Any questions on that? No? Good? All right. So for our last example here, we have h of x equals x minus 5 over 2x squared plus 7x minus 4. So before I started here, I went ahead and factored this. Right? You could use split the middle, guess and check, whatever you need to do. Again, the factorizations will make finding the x-intercepts and the vertical asymptotes easier. The standard form will make the y-intercept and the horizontal asymptote easier. So we see that we have an x-intercept at 5, 0. Got that from the numerator. Y-intercept of 0, 5/4, because we put 0 in for x. For the vertical asymptote, you set each factor equal to 0. So that's where you get x equals 1/2. And then x equals -4. And the horizontal asymptote is y equals 0. What I like to do, and this is why sometimes I put arrows on the ends of my asymptotes when I don't on the axes, is this lies right on the x-axis. And a lot of times this happens because that's one of our big end behavior asymptotes. So what I'll usually do is I'll just extend the axis with a dashed line and then just give it a little arrowhead. Just to remind myself that there is a horizontal asymptote there. It's just sharing the same space. There is our x-intercept. Here's our y-intercept. Vertical asymptotes, we have one here at 1/2. And at -4. So again, we're going to make a sign table to kind of help us out. I mean, something you've probably noticed, maybe if not, as we look, if you have 2 vertical asymptotes, you're going to have 3 pieces to your graph, right? Every vertical asymptote chops it. You get a new piece. So let's do a sign table here. So significant values on the x-axis are -4, which is a vertical asymptote, 1/2, which is a vertical asymptote, and then 5, which is a 0. So I'm going to have to test 4 regions, correct? With our sign table. And again, I'm going to write my factored form. It's much easier to test that one. Okay, so just to kind of keep it close by. So here, let's maybe do -6. So that's a negative, and a negative. So 3 negatives is negative. Okay. So to the left of this vertical asymptote, the whole graph is negative. Now, that means our asymptotic behavior would have to go down, correct? To the -infinity. And then we know it's going to come up, and this is the end behavior asymptote. We know that it never crosses it over here because there's no x-intercepts. So this part of the graph will look something like that. Now we just need the shape. We don't know if it's going to like sit tucked in there more or be further out. We really don't care enough to investigate that, to be honest, at this point. Okay, so now let's look at this region here between -4 and 1/2. Now, you might notice there's already a value that we know in there. So if you didn't want to test it, you wouldn't have to. If you did, it would be fine too. So say we test it with -1. And you get negative, positive, which gives us a positive. So that means we never cross the x-axis between these 2 vertical asymptotes. So it must look something like this, right? Now that's where sometimes they get some weird shapes, like some goofiness, but we're not going to catch that. So we're just going to do something like that. We could write this asymptotic behavior using limits if we needed to. Right? Make sure we haven't forgotten about that. And then, let's see, here we have two regions. Let's try the number 2. If we get negative, positive, positive, which is negative. And then here if you try, like, say 10, it's all positive. So it must be positive. So it tells us this interval is negative. This interval is positive. So it's kind of nice. We just crossed over the horizontal asymptote. It happens all the time. Now it's still going to approach it as it goes to the end. So we're looking at probably, we said it's going to go down here, coming up and crossing, and then kind of just going up a little bit and then coming back down and just settling down right on top there, where it is going to be a positive number. So that would be something like, now the way I know that is I just graphed it sometimes. Like you could find points if you really wanted to, but you know, the way that you want to check your work here is just graph it on your calculator. It'll show you what you get. So are we good there? All right, very good.